But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
Hello everyone and welcome to this session on CAP theorem by Intellipaat. CAP theorem is the most basic and widely used theorem in the field of distributed systems. If you ever find yourself in a system design interview, there is a big chance that the CAP theorem might come up. In this video, let us understand what C, A and P mean in this theorem. And I will be taking up a scenario and explaining the concepts of the theorem as we go along the scenario. Now let us take a look at the agenda for this video. So firstly, I'll be explaining some basic concepts, that is, I'll be explaining what C, A and P stand for in the CAP theorem. Followed by, I'll be explaining the core of CAP theorem itself. And then lastly, I'll be explaining something called as the Pace LC theorem, which is just an extension of the CAP theorem. Now that we know what we will be learning in this session, let us move on to the first topic, basic concepts. Consider a distributed database store that stores information of some type of data at some intervals. This system is called a distributed system. It essentially means a network consisting of several nodes that seems to the user as a single coherent system. An example of a distributed system is Facebook. Now let us see what consistency here means. Consistency means that every read in the system receives the most recent write or an error. It must never return an older write. Now A stands for availability. Availability in this theorem, in this context, means that every request receives a non-error response without the guarantee that it contains the most recent write. So even if it returns the wrong result, it will still respond with something to the user. Moving on to the next concept, that is P in the CAP theorem. It stands for partition tolerance. Partition tolerance essentially means that the system continues to operate despite an arbitrary number of messages being dropped, or it can also be delayed for a few minutes or seconds by the network between the nodes. So this is what CAP stands for. C stands for consistency, A stands for availability, and P stands for partition tolerance. Now that we know some basic concepts, let us move on to the core of the theorem itself. So CAP theorem says that when a network partition or a network failure happens, it must be decided between two options. That is, whether to cancel the operation and thus decrease the availability but ensure consistency, or you can also go with proceed with the operation and thus provide availability, but you will be risking consistency. So as you can see in the Venn diagram below, you can never have all the three concepts here. So if you have consistency and availability, you cannot have partitioning as well. That is, you can either have CA, CP or AP. You can never have CAP, all three together in a distributed network. Thus, if there is a network partition, one has to choose between consistency, availability. Note that the consistency as defined in the CAP theorem is quite different from the consistency guaranteed in the ACID database transactions. So, the computer scientist who invented this theorem was Eric Brewer, and he argues that the often used 2 out of the 3 concept can be somewhat misleading because the system designers need to only sacrifice consistency or availability in the presence of partitions, that is, in the presence of P, that is network partition. But that in many systems, partitions are rare. And now we will move on to the last topic of this video, which is the Pace LC theorem. The Pace LC theorem, introduced in 2010, builds on the CAP theorem by stating that even in the absence of partitioning, there is another trade-off between latency and consistency. Pace LC means that if partition P happens, the trade-off is between availability and consistency. So this is what CAP theorem is. So up to here, CAP theorem holds good. And now in the else part is the extension of the CAP theorem, that is the whole Pace LC theorem. So it says else the trade-off is between latency L and consistency C. So, to take up an example, blockchain technology sacrifices immediate consistency for availability and partition tolerance by requiring a specific number of confirmations. Blockchain consensus algorithms are basically reduced to eventual consistency. That's it from my side, guys. Have a nice day.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ENICT IIT Guwahati. The course link of which is given in the description below.